In this video, we're going to discuss factoring difference of squares. So we're going to start out with just a reminder on how we get a difference of squares. So the way that we get a difference of squares is when we multiply two binomials together that are almost exactly the same, except one has an addition sign and one has a subtraction sign. So when we go to FOIL this, we would get x squared minus 5x plus 5x minus 25. And this is where the middle two terms cancel out. So again, that can only happen when we have one positive and one of the terms negative. So those cancel out and we are left with x squared minus 25. So it's called a difference of squares, remember, because each term is a perfect square. So x squared is a perfect square, 25 is a perfect square, and it's a difference because they are being subtracted. So when we're factoring these, we're going to start with kind of the answer here, and we're going to work back to what did they multiply together to make that difference of squares. So let's start by factoring x squared minus 9. The first thing we need to do is check to see that both of our terms are perfect squares, and they are. X squared is a perfect square and 9 is a perfect square. And then we also need to make sure that it's a difference, which it is. So remember, this is going to factor into two binomials that are exactly the same, except one has an addition sign and one has a subtraction sign. So then what we're going to do is we're going to take the square root of the first term. So the square root of x squared is just x. So we would have x here and x here. And then we have the square root of the second term. So the square root of 9 is 3. So they would each get a 3. So this factors into x plus 3, x minus 3. And remember, we can check that by FOILing. X times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. And 3 times negative 3 is negative 9. Again, because we have one positive and one negative, those middle terms will cancel out. So we're just left with x squared minus 9, which is what we started with. So we know that this is the correct factored form. The next example has more things in it, but it's still a difference of squares. So we're going to start by looking at each of the terms. 49 is a perfect square, x squared is a perfect square, and 16 is a perfect square, and they are being subtracted, so we know this is a difference of squares. So it's going to factor into two binomials that are exactly the same, except one has an addition sign and one has a subtraction sign. So we're going to start with the first term, and we're going to take the square root of 49 x squared. So the square root of 49 is 7. The square root of x squared is x. So they're both going to get a 7x. And then we'll look at the second term, which is 16. The square root of 16 is 4. So they each get a 4. So this factors into 7x plus 4 times 7x minus 4. The first thing you should notice about this next example is that the 2 and the 8 are not perfect squares. But remember, the first thing we should always do when we factor is to factor out a GCF. So we can see that 2 and 8 are both even, so we can factor out that 2, and that will leave us with x squared minus 4. Now, what we have left inside the parentheses is a difference of squares, so we can go ahead and factor this further. So remember, this will factor into two binomials that are exactly the same. One has an addition sign, one has a subtraction sign. The square root of x squared, our first term here, is x. So they each get an x. And then the square root of our second term which is 4. That square root is 2, so they each get a 2. So that difference of squares factors into x plus 2, x minus 2. But we have to make sure that we include the GCF that we factored out first. So here is our final answer. This next example has two variables, but we're still going to factor it the same way. So 64 and a squared are both perfect squares. 25 and b squared are both perfect squares, and we have a subtraction sign here, so we know we can go ahead and factor this. And there is no GCF here, so we don't need to factor anything out first. So this is going to factor again into two binomials that are exactly the same. One has an addition sign, one has a subtraction sign. We'll start with the square root of 64a squared. So the square root of 64 is 8. The square root of a squared is a. So they're each going to get an 8a. And then we'll do the same thing with 25b squared. So the square root of 25 is 5. The square root of b squared is b. So they each get a 5b. So this factors into 8a plus 5b, 8a minus 5b. In this example, we can see that we have perfect squares. So x squared is a perfect square, 25 is a perfect square. The problem is we do not have a difference here. We have a sum or an addition sign, so this cannot be factored. This is what we refer to as prime. There is no way for us to factor this because of this addition sign. Remember, in order to get a difference of squares, we have to have a minus sign. The first thing you should notice about this example is that we have a negative leading coefficient, so our first step is to factor out that negative, which remember means we change the sign on everything. Now, inside the parentheses, we have a difference of squares, so we're going to factor that. Two binomials that are exactly the same. One has addition, one has subtraction. The square root of x squared is x. The square root of 121 is 11. And then we need that negative sign that we factored out at the beginning. So this factors into negative x plus 11, x minus 11. So what I want to point out with this last example is that we do not want to rewrite this with the a squared first. We want to leave it as 81 minus a squared. So 81 is a perfect square, a squared is a perfect square, and we have a difference. So we're going to go ahead and factor this into two binomials. One has an addition sign, one has a subtraction sign. And we're going to start again with 81. So the square root of 81 is 9. So they each get a 9. And then the square root of a squared is just a. So they each get an a. So this factors into 9 plus a times 9 minus a. We do not want to write this as a plus 9, a minus 9. The reason is if you go ahead and FOIL this, you would actually get a squared minus 81, which is not what we started with. We started with a positive 81 and a negative a squared, and in this case our a squared is positive and our 81 is negative, so it's not the same, so we cannot write it like that.